title of this talk is the Equilibrium Existence Duality, Equilibrium with Indivisibilities and Income Effects. And this is joint work with Elizabeth Baldwin, Omer Edhan, Paul Klemperer, and Alex Teytelboym. This is a paper about when competitive equilibrium exists in markets for indivisible goods. And the case with indivisible goods is very different from the case with divisible goods, because unlike in the case of divisible goods, equilibrium does not exist in general when goods are indivisible. Most previous work on this topic has assumed that utility is quasi-linear in money. So that is, that an agent's utility for a quantity of money and a bundle of goods is given by the sum of the amount of money and some valuation applied to the bundle of goods. The quasi-linearity assumption has been made in part because it's technically useful. For example, it allows one to characterize Pareto efficient allocations in terms of solutions to a welfare maximization problem, where social welfare is defined to be the sum of agents' valuations. However, the quasi-linearity assumption is quite restrictive. For example, it implies that an agent's endowment doesn't affect its demand for goods. So for example, a consequence of quasi-linearity is that if an agent has more money, or an agent's endowment of a house becomes extremely valuable, that's not going to make the agent change demand, what other house it demands. So that is, if my house appreciates, quasi-linearity is going to say, I'm not going to try to move to a more expensive house. In this paper, we take a new approach to analyzing economies with indivisible goods and non-quasi-linear utility. And the approach we take is we use a duality to, in effect, quasi-linearize agents' preferences and therefore reduce to the more well-understood quasi-linear case. The starting point for our analysis is some old duality from consumer theory. So this is not new to us. It's usually done in the case of divisible goods, but everything works basically the same with indivisible goods. So consider the usual consumer problem of maximizing utility given an endowment of money and of goods and prices subject to a budget constraint. The solution to this problem is called Marshallian demand. The problem we're going to consider is a natural dual of this, where instead an agent has a fixed utility level and minimizes the expenditure needed to obtain it. This dual problem, the solutions to this dual problem are called Hicksian demand. And it's going to be important for us to think about two different types of ways in which Hicksian demand can change. Right? So one way in which Hicksian demand can change is in response to a change in prices, holding the utility level fixed. And those types of changes are called substitution effects because they reflect an agent's change in demand in response to a change in relative prices. Another type of change in Hicksian demand is the ones that come from changes in utility levels, where prices are fixed. And the second type of change is what's called an income effect, because these second type of changes correspond to changes in Marshallian demand in response to a change in an agent's money endowment or income. When preferences are quasi-linear, one only sees substitution effects. Income effects are absent. The key first step in our analysis is to interpret the dual consumer problem as a quasi-linear maximization problem. And this allows us, by combining these quasi-linear maximization problems over all agents, we can form what we call Hicksian economies, which are quasi-linear economies in which agents have fixed utility levels rather than fixed endowments. By construction, each Hicksian economy only reflects agent substitution effects, right? Because the utility levels are fixed. And when you fix utility level, Hicksian demand only captures substitution effects. And our key technical result is what we call an equilibrium existence duality. And this result says that equilibrium always exists in the original economy if and only if it always exists in each of the Hicksian economies. Right? So this relates the existence question in a non-quasi-linear economy to the existence question in a family of quasi-linear economies. And while this result may seem technical, it has two key consequences, which I'm going to describe in more detail through the course of the talk. The first, it tells us that really substitution effects are what determine whether equilibrium exists, right? Because in each Hicksian economy, one only sees substitution effects. And so essentially income effects, while they may matter for how equilibrium looks, they don't really affect whether one exists. Second, we get new domains for the existence of equilibrium with non-quasi-linear utility from previous results on when equilibrium exists with quasi-linear utility. And how is that? Well, if you take some condition for the existence of equilibrium in quasi-linear economies, if each Hicksian economy satisfies that condition, then we know by the equilibrium existence duality that equilibrium also exists in the original economy with non-quasi-linear preference. So I want to start out by describing our setting more precisely. It's essentially a standard setting of an exchange economy with indivisible goods and money. So there is some finite set that we denote by I of indivisible goods, as well as money, which is the numerator, and we'll denote it by the zero as the zeroth good. There's also some finite set that we denote J as agents. And there's some fixed total endowment of indivisible goods in the economy. Like you might say there's only one unit, there's exactly one unit of each house available. Agents' preferences are comprised of three parts. So first, each agent has a set that we'll denote by xji of binary vectors, which is a set of feasible consumption bundles of indivisible goods. So for example, this set could say that, well, an agent wants to buy at most one house. And I'm assuming that feasible consumption bundles all consist of binary vectors. So each agent wants at most one unit of each good, just for sake of simplicity during the talk. In the paper, we allow for agents to demand multiple units of each good. Agents also have a lower bound that we denote by xj0 underline on their consumption of money. So it's not, we don't allow an agent to borrow arbitrarily large amounts of money. And that, because there's this lower bound on consumption of money, the value of an agent's endowment is going to affect their purchasing power. Each agent also has a utility function, which is defined over feasible consumption bundles and takes values in some interval. And technically, note that utility is only defined when the consumption of money is strictly greater than the lower bound. So the implicit assumption here is that a little bit of money above the lower bound is essential for agents. And we also assume some regularity conditions on utility that I don't want to get into. In terms of equilibrium, what we think of is we suppose that each agent is endowed with some feasible consumption bundle, and they can exchange goods and money among themselves, and we consider competitive equilibrium in the exchange economy. We are going to look at these economies using the dual consumer problem. So I want to say what that is more precisely. So given a utility level U and price vector P, we define the agent's Hicksian demand to be the set of consumption bundles x star I of indivisibles that are the indivisible component of a bundle that's comprised of x star 0 money and x star I indivisibles that minimizes agent's expenditure, where expenditure is defined as the sum of the value of money and the total value of the indivisible goods, overall subject to the constraint that the bundle must deliver utility at least to you. So this is the dual consumer problem. The reason that this is quasi-linear, or it can be interpreted as a quasi-linear maximization problem, is, well, look, the objective is quasi-linear in money, and by using the constraint to solve for x0 or money as a function of the utility level and the bundle of indivisibles, we can rewrite this as a quasi-linear maximization problem. So to be a little bit more precise, what we do is we define agent J's Hicksian valuation at a utility level U to be, which we denote by VJH, to be VJH of a bundle xi of indivisibles and a utility level to be minus of the the amount of money that's needed by the agent to achieve utility level U when taken in combination with the bundle x star I of indivisibles. So because we're solving for the amount of money that you need to get to some utility level, there's an inverse function that comes up here. And by construction, Hicksian demand is given by a quasi-linear maximization problem for the Hicksian valuation. Right? So Hicksian demand is the set of bundles that maximize the Hicksian valuation minus the cost of the bundle. So now I've explained to you this kind of quasi-linearity at the agent level. I want to explain to you now how to do the duality at the level of the economy. What we do is we just combine these Hicksian valuations. So formally, we define the Hicksian economy for a profile of utility levels to be the quasi-linear economy in which agent J's valuation is just her Hicksian valuation at the utility level in that profile. And by construction, each Hicksian economy reflects only substitution effects because agents' utility levels are fixed. And so now I can state our equilibrium existence duality more precisely. What it says is that competitive equilibrium exists in the Hicksian economies for all profiles of utility levels, if and only if competitive equilibria exist in the original economy for all endowment allocations. So why does this tell us that it's substitution effects that determine whether equilibrium exists? Well, consider any condition that ensures the existence of equilibrium for all endowment allocations in an economy. By the equilibrium existence duality, that's equivalent to the condition ensuring the existence of competitive equilibrium in the Hicksian economies for all profiles of utility level. But each Hicksian economy only sees substitution effects. And so any such condition can be written as a condition on substitution effects alone. So that's the sense in which it's substitution effects rather than income effects that determine whether equilibrium exists. In the rest of the talk, I just want to give you some examples of what the Hicksian economy looks like and how this equilibrium existence duality works. So the simplest example is, it's an old example. It comes from Quincy 84. It's called a housing market. And what the idea is in this example is that you have some agents. Each agent comes to the market with a house, and each agent wants to leave the market with a house. And agents can exchange houses and exchange money. And one looks at competitive equilibrium. What does the Hicksian economy look like if we take the original economy to be the housing market? Well, once you fix utility levels, there's no income effects, everything is quasi-linear, so the endowments don't matter. In effect, then, one has some houses and some agents, and an equilibrium just needs to assign houses to agents and determine the payments. And so that's actually a different model called the assignment game of Koopmans and Beckman. So to remind you, what the assignment game is that there's some objects and there's some unit demand agents with quasi-linear references, and the model finds an equilibrium in this assignment market. So given that what we know is that if we start off with the housing market, each Hicksian economy is an assignment game. And Koopmans and Beckman showed that equilibrium always exists in the assignment game. This is a quasi-linear context. And so by the equilibrium existence duality, it follows that equilibrium always exists in the housing market. Now that was actually known, Quincy and others showed it, but their arguments relied crucially on agents having unit demand for goods in the housing market. Our approach doesn't really rely on that. And so I want to now explain to you what condition is really driving existence of competitive equilibrium in this example, in a way that allows for the possibility that agents might demand multiple goods instead of just one good. When thinking, one might think that existence is driven by some form of substitutability. And the most well-known previous result in that vein is Kelso and Crawford's result showing that equilibrium exists under their gross substitutability condition. So to remind you what this condition says is that raising the price of one good can never make Marshallian demand for another good fall. So raising the price of one good may make you substitute toward other goods, but it's never going to make you substitute away from another good. That's the intuition behind gross substitutability. But note that because this condition is imposed on Marshallian demand, it's implicitly a condition on both income and substitution effects. And so in fact, it's not satisfied in the housing market. It is satisfied, it turns out, in the assignment game, but once one puts in the income effects in the housing market, gross substitutability is not satisfied. So to see why, consider some agent, Martine, in the housing market, who owns a house that I'll denote by circle, and is considering selling her house and buying either a luxurious house, which I'll denote by diamond, or a Spartan house, which I'll denote by triangle. And let's suppose that if she only wants to buy this luxurious house diamond, if she's going to have enough money left over, for example, to furnish the house or something, then an increase in the price of her house is going to make her effectively richer. And so she may decide, instead of buying the Spartan house triangle, to buy the luxurious house diamond. So because of, once one goes outside the quasi-linear domain, it's possible that an increase in the price of circle can make Martine stop demanding diamond. Right? And that's a violation of gross substitutability. So one might ask then, well, what's really driving existence in the housing market if it's not gross substitutability? And our answer to that is, well, gross substitutability isn't actually what drives existence in Kelso and Crawford's setting. There's a different condition that is weaker than gross substitutability that's satisfied in the housing market and that ensures existence. And this condition is a condition called net substitutability. It's exactly like gross substitutability, except instead of imposing a condition on Marshallian demand, you put a condition on Hicksian demand at a fixed utility level. It might not be clear that putting a condition on Hicksian demand is actually weaker than putting a condition on Marshallian demand, but we show it is. And the idea is that net substitutability is only a condition on substitution effects. It doesn't restrict income effects, and it's satisfied in the housing market. And it turns out actually that net substitutability is sufficient for the existence of equilibrium. So why is that? Well, let's take a market in which net substitutability is satisfied. Well, then we know that each Hicksian economy is going to look like gross substitutability is satisfied. Because in the Hicksian economies, there's quasi-linearity, and so there's no distinction between gross and net substitutability. Marshallian and Hicksian basically look the same. We know from Kelso and Crawford that equilibrium exists under gross substitutability. And so we know in our context that equilibrium is going to exist in every Hicksian economy. And so by the equilibrium existence duality, it follows that equilibrium exists in the original economy. And so the conclusion is that equilibrium exists under net substitutability. Because net substitutability is a strictly weaker condition than gross substitutability, this tells us that it's really net substitutability that drives existence in Kelso and Crawford. And this also, net substitutability also subsumes the housing market of Quincy. Now, this general idea of leveraging a quasi-linear equilibrium existence result to get an existence result for settings with income effects goes beyond just the case of substitute. If you take any condition on demand or on valuations that ensures the existence of equilibrium with quasi-linear preferences, you can just put the same condition on Hicksian demand or Hicksian valuations, and the equilibrium existence duality will tell us that that ensures the existence of equilibrium with income effects. And so in the paper, we do this to get a version of Baldwin and Klemperer's unimodularity theorem for settings with income effects. What that result tells us is it gives necessary and sufficient conditions for a combination of substitution effects to guarantee the existence of equilibrium. So to conclude, I think the main point in our paper is that we show that one can analyze economies with non-quasi-linear utility by using the Hicksian economy, which is quasi-linear. This lets one kind of quasi-linearize and go from a a priori more complicated setting to a simpler and more well-understood one. And our equilibrium existence duality tells us that it's substitution effects, not income effects, that really determine whether equilibrium exists, and gives us a way to move every quasi-linear equilibrium existence result to get equilibrium existence results in settings with income effects. I think one question that our work leaves open is about how to find equilibrium with income effects. So the proof of our equilibrium existence duality is via topological fixed point argument, non-constructive. And so it would be interesting to think about whether there are efficient algorithms to find equilibrium in settings with income effects. Thank you all for listening.